Welcome to Python Basics with EJD. We are gradually coming to the end of this playlist. If nothing else comes up, I have just two videos to go, this one and the next one after it, and then it will make it 60 videos in all, and we'll be done with Python Basics. So I think that if you can get through this whole series, I mean, these whole videos, you should be very strong Pythonically, if I can say that, right? So testing and debugging in Python is what we are considering here. Having considered different packages, just even if it is just a kind of overview of those packages and the kind of things they do, right? Maybe by now you already have found the packages that are relevant to the kind of things you do. All right, let's talk about testing and debugging in Python. So testing and debugging are two pillars of reliable software development. I mean, this is particularly useful for software developers, right? So testing ensures that code works as expected, while debugging helps locate and fix errors when things go wrong, right? So testing and debugging. Okay. So if you want code to work as expected, you will test them. For instance, if you are written like, a very simple one, like if you are written formula to calculate the area of a circle, so you want to like maybe you already know what the area of the circle should be. So by the time you write your code and you put in the parameters, if you don't get the right answers, then you definitely know that something is wrong somewhere, right? And once so that's for testing. For debugging, right? So if you have an issue, you can debug, you can correct the wrongs, you can fix the errors. So Python provides a rich ecosystem for both testing and debugging, right? Ranging from built-in tools like unit test and PDB to third-party libraries such as pytest, right? So let's look at why testing and debugging actually matter. Of course, obvious. I think it's quite obvious that testing and debugging really do matter. So the first thing is about reliability. So you need to catch errors early and reduce bugs in production. And maintainability, easier to refactor code without breaking existing functionality when you do testing and debugging. Then confidence, developers and users can trust that the system behaves as intended. Then faster iteration, automated tests quickly validate changes, right? Then let's talk about testing in Python. What does testing look like inside of Python? We already have a glimpse of that, talking about the inbuilt and third-party packages or libraries we talked about the other time. So testing in Python, there are different types of tests in Python. We have unit testing. This is testing individual components, like you're testing the functions or classes on their own. Then you can do integration testing, testing how components work together. So having defined your classes, functions, and everything, or whatever else you have, you want to see if everything goes together. Then see what about system test? I mean, it's possible that you have functions and classes all working very well on their own as units, but then they are not working together. Maybe you need to connect a function with a class with another thing, and all that. Maybe that's necessary. So then there's system testing. That's testing the complete application. So having done everything overall, then you test the complete application. Then you can do regression testing, which ensures ensuring changes don't break existing features. So if there's a change, does it break the features you currently have? That's regression testing. So we have unit integration system and regression testing. If you can, like, you can say UISR testing, unit integration system and regression. So let's talk about the unit test framework, which is inbuilt in Python, right? So unit test framework built in Python. So overview, part of the Python standard library inspired by JUnit, that's Java. So the structure, it creates test cases by subclassing. So using unit test case, use assertion methods like assert equal, assert true, assert raises, then organize tests into suites and run them with test runners. Then advantages, no external dependencies, and then familiar XUnit style pattern. Then limitations, it has a verbose syntax, so the syntax can be a lot. Then less flexible compared to modern libraries. So unit test is inbuilt in Python, but it's less flexible compared to modern libraries. Let's look at a very simple example. So we have import unit test. So you just define a simple function to add A and B. So and it will return the sum of A and B. So then you can do class. You create a class, that's OOP concept now. Class test math, unit test dot test case, define test add. So you are testing if this works well. Then this is very simple, by the way. So it's very, we can easily inspect this without doing any special thing, but it's good to use a very small thing like this to really understand the concept. Then so under this class now you define a function, the test add self, then self assert equal. So you see this whole assert equal thing that we saw up there now. So using assertion methods now, that's part of the structure of unit test. So it says self dot assert equal, then add 2, 3. The answer is 5. So you are giving it the right answer. Then self dot assert not equal 2, 3. That when you add 2 and 3, the answer is not 6. So in this case now, uh, if you run this now, you see that we'll see what goes. Of course, this is the first time we're running, so everything seems to work well. So I guess we are in order, like no error thrown up. So that means the system is working pretty well. So if you add 2 and 3, it gives 5. So that works well with the model. That's with the function defined. That's why we don't have any error thrown up. Then we have the PyTest framework. So overview for the PyTest now. PyTest is a third-party thing, so it's a more modern, feature-rich testing library. And the key features: no need for test classes. You don't need test classes. Functions are just enough. So rich assertion introspection is another advantage of this. Then features for test setup and teardown. Powerful plugin ecosystem. Advantages: it has concise syntax, extensible and widely adopted. Limitations: it requires installation. I mean, which is not a big deal. We already get to install things in Python, by the way, right? So if that's a limitation, then we don't care because we always install. The only thing is that the other one we considered is built in, so you don't have to install anything. But if you compare the conciseness of the syntax for PyTest, you may want to go for PyTest, right? So pip install PyTest like that. So like here, we're installing it. So PyTest test underscore math. So if you have written a code, so it says file or directory not found. So there's no directory like test math.py. So what we are doing now is to now write, we now want to write it. I guess this should come afterwards. I'm trying to see. Okay, but I guess we can do everything together. So if you could use this now, yeah, writing test math.py. So we have done the whole assert thing here. So everything works well. So in fact, I don't think we need this any longer because everything is done here. So if there was an error, we would have detected it right here because we have so rich assertion introspection. So yes, you see, we have defined the function we want to do. Then we are writing the maths.py. So it says writing test underscore math.py, which is okay. And then we have defined this and everything is working fine. If not, there would have been an error. Okay. I just want, let me change this one now and say, um, 2, 3 is 5, right? And then 2, 3 is not equal to 6. Okay, I'm trying to see how I can tweak this to make it look. Okay, what if I change this to 5? Let me see what happens. I just want to see something. Okay. Yeah, nothing is happening. Okay. So 6. All right. So, I mean, if you want to investigate this further, you can, really check it out. But I feel that since no error is thrown up, at least the 2, 3 thing is working good. So 2, 3 is 5, then 2, 3 is not 6. Then we can check unit test versus PyTest. So you can drill deeper into this if you're interested in checking about testing and debugging. So feature for the library, right? Unit test is built in, you no need to install. PyTest is third party, you need to install it using pip install PyTest like we did. Style, unit test is class-based, while PyTest is function or class-based. Assertions, unit test has verbose assertions like self.assert, blah, blah, blah. And PyTest is just natural, just say assert X if X equals Y, is X equals Y, that kind of thing. Then fixtures, setup, tear down, and then rich fixture system, plugins, limited extensive ecosystem, ease of use. Unit test is beginner friendly, while PyTest is more concise and modern. I still feel that there should be something else we need to do about this. But so let me explore. Let me say indicate indicate whether 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 there is whether there is error or not. Okay, let me see what we can get out of that. Because I still feel there should be something more beyond just writing and overwriting. We should be able to know this code is the code is in divisible cells is designed to set up a test. It doesn't produce any errors when run. So how do we know? How do we know there is no bug? Okay, how do we know there's no bug? Okay, now it's taking us to somewhere else. So I think I don't want to. There's no point. Okay. The test part. Okay. We don't know there's no bug just by looking at the code. We need to run the test to see if they pass. Here's how to run pytest. The test file we created. The test passed, which indicates there are no bugs. Okay, good. Aha, I think this is where the issue is now. So for this one now, uh we need to run it. So for where do we have the pytest now? Okay, I think I deleted pytest somewhere. So we actually need to after writing this thing now, we need to run the pytest to be sure that there's no bug in it. Okay, so once we don't have error for after running this, we know we are good to go. So test maths.py. So test session starts. So we don't have any issues. Everything is fine. One passed in 0.01 seconds. Excellent. So, and we've looked at comparison between unit test and PyTest, right? So debugging in Python now. So that's about testing up there. We talked about unit test and PyTest. So talking about debug, and then you need this PyTest, uh, test underscore maths. So now there's no error here. That means the test is passed, right? So thankfully I was able to get that. Then debugging in Python, common debugging approaches in Python include print debugging. So adding print statements which is quick, but it can be messy. Then yes, I mean I get to do this print thing a lot. Like I put print to see what's happening every line of the code, right? I want to see the result if it is right or not, so I can know if there's error somewhere. But it is quick, but it can be really messy because you have to write print everywhere you do something, you just want to see print, 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 print. That can be quite a lot. Then you can use logging, which is structured tracking using Python's logging module. Then you can have interactive debugging, step-by-step execution with PDB. That's like Python debugger, right? So debugging with PDB. So the Python debugger PDB is a built-in module for interactive debugging. How do you invoke it? So you start import PDB. You have pdb.set underscore trace in your code or run script with debugger. So in this case, now we can just try to run this. All right. So script py does not exist. I think we have to write the script py somewhere. Um, did I do that somewhere? Um, okay. I guess, okay, here now. Um, let's invoke, let's invoke the AI power here. Write script py, write script.py, right? Write script.py. Yeah. Since it doesn't exist, we want to really write it. Then, okay, so we can run that. Okay, so that works. So we can just bring this, we can take this up now. This can then go. So we had the script py does not exist in here. So it means that before it, we can have a code. So we write this now. So we run the script py, which is done, and then so the script py is done now. So this will cause a zero division error because we are divided by zero. So by the time we now run this now, then it's going to tell us, maybe it's going to give us an information about that script.py. It should, right? So just like the py testing told us everything was fine because when you add two and three, you get five. Hmm. And we have common commands like next line, step into function. C is continue execution until breakpoint. L is list source code around current line. P is var, that's print variable value. Then Q is quiet debugger. So I guess this is reading through, but the lines are few, so I wonder why it's taking so much time. I hope it gets done really soon. So here we define a function, faulty function, where we are, which gives us y equals x over 0. This will cause a zero division error, and then you return that y. So result is faulty function. If you put 10, uh, so it takes x, right? So 10 divided by 0, print the result. The result should actually be um faulty because we don't divide by 0. It's going to be undefined. But I still wonder why this is taking so much time, really. So, but I mean, for common commands, right? We know NSCLPQ. Next line, step in the function, continue execution until breakpoint, list source code around current line. P is for variable, pvar, that's print variable value. Q is quit debugger. So we can see an example down here when we get there later. Okay, we actually have a function down here. Aha. So I think that this division is going on and on forever because we have um we have an endless loop, right? Because that normally I was expecting an error to be out to be given, but this is taking too long, so we can just stop it. Let me just stop it. Yeah, we can stop it because it's giving like an endless loop. Okay, so we go on. So we can take this example too. So define divide A B. So import PDB dot set trace, commenting on the debugger for now. So if B is equal to 0, oh, were we supposed to import? Did we not import PDB somewhere already? All right. Oh, it's built in, so we don't have to import here. We don't have to. So here now, if B is 0, print error, division by 0 is not allowed. So in this case now, we just run this and it tells us division by 0 is not allowed. Then here we have no error here. Then, and this one just gives us, so error, division by 0 is not allowed. So for 8, we have none or is an exception depending on desired behavior. And for this now, the answer is just 5. So then you can inspect variables step by step before the crash. So something like that for debugging. So we talk about the workflow. So we can talk about the workflow. Yeah, so testing plus debugging together can actually go together. So you can do write test first, that's TDD or alongside code. Run test to detect failures. Then use PDB to inspect failing tests. Fix issues and rerun tests until all pass. Automate with CI/CD tools, GitHub Actions, GitLab CI. And with this, we come to the end of this interesting video on testing and debugging in Python. So you want to drill deeper into these three things now: pytest, uh, unit test, and of course PDB for debugging, Python debugger. So you want to explore them better to have a deeper understanding if you want to know how to debug like that. But of course, once I figure that most people already have a way they go about it. Like for me, I keep using that print thing a lot, so I just keep printing to see if anything goes wrong at any point in time so I can easily correct. But we have standard ways of debugging and testing in Python, like we have seen pytest, unit test, and of course, PDB Python debugger. So with this, we come to the end of this very interesting video. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel free to let me know. So after this, I think I have one more video and we'll be done with this playlist, except there's a request or something else does come up. All right. Thank you so much for listening. If you have not subscribed already, of course, you want to go ahead and subscribe right away and click on the subscribe button. So click on the notification bell so you can always get alerted each time a new video is released. Then having subscribed, you want to take it a step further. You want to click on join and become a member of this channel. And that comes with some special privileges for you. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. So I come your way again. Keep doing Python right. Bye.